Hello everybody, this is the sixth video clip for the first chapter. So for this video clip, we're going to determine, or to determine the behavior of the function, if the function's like unbounded, However, for the unbounded function, it can go either like pretty large, in terms of positive, or pretty large in terms of negative. So we are going to say that, hey, whether your function f of x, as your x goes to some point, and then your function f of x will goes either to a pretty large positive number or a pretty large negative number, but sometimes for negative we say like pretty very small, and this a can be like a from the left, a from the right, or either positive or negative infinity, depends on the situation. So for example, let's look at this function. So you see that as your x goes to a, go close to a on the left, your function will getting larger and larger and larger without bound, you see. So for this one, we are going to say that as your x goes to a from the left, your function will goes to positive infinity. However, if you look at this one on the right, uh, okay so the function value will getting smaller and smaller and smaller, you see, getting smaller and smaller, without bound again. So we are going to say that this limit as your x goes to a on the right of your of a function f of x, it will goes to negative infinity. okay on the other hand, if you look at the pretty like far away on the right, so it is like as your x goes to positive infinity, you see again that your function like keep going up, without bound. So it means that as your x goes to positive infinity, your function also goes to positive infinity. And on the other hand, if you look at the far on the left, you see that your function keep going down without any bound again. So it means that as your x goes to negative infinity, the function values also goes to negative infinity. Again, this is not always the case. This is just happen that as your x goes to infinity, your function just happen to go to positive infinity as well. This is not always the case. And this one, as your x goes to negative infinity, your function happen to be goes to negative infinity as well. It's not always the case. And sometimes this kind of line is called the vertical asymptote. Vertical asymptote. And this vertical asymptote, it means that your graph, will just go close to this line but will never touch or cut this line, this one as well. And it will be the line x equals to a, that your function cannot take place or cannot define a value of your function here. So all these, it's just the thing that we have been explained. For example, we can see from the graph that as your x goes to a from the left, it will goes to positive infinity. And similarly, as your x goes to a from the right hand side, it goes to negative infinity. And we also have been noticed that as your x goes to positive infinity, your function goes to positive infinity. And on the other hand, as your x goes to negative infinity, it goes to negative infinity as well. So please note that the symbol positive or negative infinity is really not a real number. So all these things, we first of all, we need to say that the limit, as your x goes to a, let me do it this way. So it means that at the beginning, we need to say that this limit, actually does not exist in terms of a real number. However, the behavior or the trend of that function, okay, even though it does not exist, but we still can, roughly speaking, the behavior of the function as your x go close to a and it goes to negative infinity. This one as well, we are going to say that this one, the limit does not exist, okay? The limit does not exist, but the behavior of a function close to that value becomes either positive or negative infinity. Are we okay? Okay. And some of the function that we may need to know the behavior. Okay. For example, actually one of them is also the exponential. Okay, so for the exponential, for example, e to the x, we know that as your x goes to infinity, the e to the x will goes to infinity, but as your x goes to negative infinity, e to the x will go close to what? To zero. So we have this one, okay, of e to the x, and the limit as your x goes to negative infinity of e to the x will be 0. Okay, and also for the log, okay, so the graph look like that. So it go like pretty large and this one will go pretty small. So it means that as your x goes to go to 0 on the right, okay, you see 0 is here and this one is go to 0 on the right, it will goes to negative infinity. But if your x goes to positive infinity, the log of infinity will be a pretty large number, positive infinity as well. Okay, and for the tangent, okay, for the tangent, we have this kind of curve, okay, which is this one, right? Okay, so here is pi over 2, there is negative pi over 2. Okay, so it means that if you go to pi over 2 on the left, you see on the left, your tangent will goes to positive infinity. Okay, but if you go to negative pi over 2 on the right, your tangent will goes to negative infinity. Okay, another one that you may need to keep in mind is the arctangent. Okay, it's just the other way around. It look like that. Here's pi over 2. There's also negative pi over 2. Okay, so we have x to infinity of the arctangent. Okay, this one is the arctangent. Okay, but this one, the limit exists and it will goes to what? Pi over 2. Okay, and if you let your x goes to negative infinity, the arctangent of x will goes to negative pi over 2. So all these function and the graph of this function you may really need to keep in mind. Okay, like how we find the limit. Okay, because we most of the time we are going to use this kind of knowledge, okay, and this kind of graph to find the limit. Okay, and sometimes you don't really know. Okay, go back to our section. This section actually we concentrate on how to determine whether the limit, okay, of this function goes to negative infinity, or how the function, I mean, whether the limit will goes to positive infinity. So to determine or to show that the limit as your x goes to somewhere, okay, of this function will be either positive or negative infinity, we need to check two things. Okay, the first step is that you just need to check a reciprocal. Why is that? Because if you say the reciprocal, it means that if if this one are going to go to a pretty large number, so this one will be 1 over a pretty large number, so then it goes to 0, isn't it? Okay, so this one, the first checking, just saying that this limit, okay, of your function will goes to either positive infinity or negative infinity. Okay, so the first one, we just know that of course it will be pretty large, but we don't know the sign. So the second one will check the sign, either positive or negative. Okay, so to check the sign, it depends on this box. Okay, whether it goes to negative infinity, goes to a from the left, goes to a from the right, goes to a, or goes to the, oh, this one is a typo, okay, a positive infinity, okay. And usually the number line will help you a lot, okay. For example, if your x goes to, let's see, or this a first, a number a real number a, okay. So if your x goes to a from the left, okay, so it means that you need to check only the left hand side of a, and then you need to check like pretty close to a, okay. So it's just a and I mean a little bit away on the right of a, okay, not too far away, okay. And then for the right hand side, you just go to the right hand side of a, so again a little bit away on the right of a, and this delta and that delta may not be the same number, okay. It depends on the function. However, if you just talking about the a itself, you may need to check both of them, okay. So check this one on the left and also on the right, okay. So you need to check like a minus delta to a plus delta to see the sign, okay. The one that we just need to know is like pretty close to a, what is the sign of the function under consideration, okay. After you know the sign, then you can determine whether it is positive or negative, okay. So on the other hand, if you're talking about positive or negative infinity, so it means that for the negative infinity, you just find a pretty large number here, sorry, a pretty small number here, such that for each and every x that is like on the left hand side of this m, you can determine one side to a function. Or this one, for infinity, you find one n such that on the right hand side of that number, you can determine only one side of the function, okay. So for this number mn and this delta, okay, you just need to pick up one number that you can determine only one sign of a function under consideration for you, okay. Oh, but before we go to that kind of checking, just roughly using the graph to check your understanding first, okay. So from the graph, actually you again know how to find the limits, okay. So for example, this one, okay, if your x goes to 2 on the left, so here it is like 2 on the left, right? So your function value keep going down without bound, so it goes to what? Negative infinity. Also from the 2 on the right, okay, so right here is your 2 on the right, so it keep going down as well, so it goes to negative infinity. So it means that as your x goes to 2, okay, the limit of this function will go to negative infinity because it got the same trend, okay. However, at 3, okay, at negative 3, this one like x goes to negative 3 on the left, okay, this one is on the left, so it will going downward, right? So it means that it goes to negative infinity. But if you talking about the negative 3 on the right, so it seems that it is going upward, so this one is positive infinity. So this means that for the limit, this one really cannot determine, so this one does not exist, and you cannot also determine what it is, okay, the trend. And as you goes to negative infinity, right here, negative infinity, you see that your graph will go close to what? 0. And as your x goes to infinity, you also see that your graph go close to what? 0. Okay. And for x go close to 5, okay, you see that both side, either on the left or on the right, it going upward there. So it's positive infinity. You see, so that's the trend. And then actually you can also get more information. For example, here, this one, the horizontal asymptote, okay, it is actually y equals to a limit as your x goes to either positive infinity or negative infinity of x, but both of them, they are going to 0. So the horizontal asymptote, the equation is y equals to 0, okay? And the vertical asymptote, okay, so it is right here, one of them, okay? So the vertical asymptote is the x value that your function does not take place, and on that x value your function either goes to positive infinity or negative infinity. So this one is one of your vertical asymptote, okay? This one as well, you see, okay? So you got 2, and this one as well. So you got 3 of the vertical asymptote, which will be x equals to -3, x equals to 2, and x equals to 5. Okay, so you got 3 vertical asymptote here. Okay, so now let's try to determine the falling limits, whether it goes to positive infinity or negative infinity. So we are going to regard this one as your f of x, okay? And why I mean, if the instruction doesn't say that you need to determine, why is that we are going to say that it goes to infinity, okay, or negative infinity? You just roughly plug in, okay? So if you plug in, okay, if you just try plug in first, you're going to have 2 and 1 over 1 square minus 1, which is 3 over 0. Okay. However, this one is not valid to write down. Just saying that this one is a small number, just close to 0. Is not really 0, but it's just a small number. So a fixed over a small, for example, a 3 over 0.1 becomes 30. If it is 0.01 becomes 300. So a fixed number over a smaller number, it becomes a large number, right? But we need to really know, like, whether it large to a positive or it large in terms of negative, okay? So from the plugin, we roughly know that it should be either positive or negative infinity, okay? But we really need to check. So by checking, we need to do 2 steps. The first step is to find a limit, okay, of a reciprocal, and a limit of a reciprocal become x squared minus 1 over 2 plus square root of x. And this one you can just simply do a plug-in, which will give 0. Okay, so don't forget that the first step, just determine that it will go either positive or negative infinity. So the second step, to check the sign, okay, to check the sign, you really need to look at a function and also the x value that it go close to, okay? So your function depends on 2 over a 2 plus a square root of x over x squared minus 1. So you just factor, right? Why we need to factor? Because your x depends on 1, right? So we really need to see like where the 1 is, okay? So here you should know that the square root always positive. So this one on top always positive, right? However, on the bottom, this factor uh, is the problem. Why is that? Because right now you are going to go close to 1 on the left, okay, on the left. So your x will be what? Your x will be less than 1. So it means that your x minus 1 always less than 0. However, you really need to determine like how far from 1 away on the left, okay? So you can, but from the problem, okay? Actually, another thing that you may need to consider is that your x can be -1 as well, right? That is another problem, is it? So you cannot go too far. For example, you cannot say that, hey, this one can be like from negative infinity to 1. That would be too far because it will be passing through that point, another problem. Okay, so you just go like pretty close to 1 but not go to that one. So the good choice can be like 0. Okay, or if you really want to have a really good choice, you can say what, you can say 0.9. That would be good, right? This one can be 0.9. It like pretty close to 1. Okay, so here you know that your f of x, because this one, roughly speaking, it will be negative, right? And then if here is 0.9, okay, so you plug in here, you got 1 plus, right? It is 1 plus something positive, so it will be positive, is it? Okay, so this means that your function will be positive, and then, I mean, let's do it this way first. So as your x go close to 1 on the left, it will be positive over negative multiply a positive, right? Okay, so the whole thing will be negative, okay, for x in this interval 0.9 to 1, is it? Okay, so you already determined that this one must be negative sign. So from the 1 and the 2, it means that this limit, okay, as your x goes to 1 on the left of this fraction equals to negative infinity. Okay, this one determine a negative, this one determine an infinity. We get? Okay, so what's the next one? The next one, again, if you plug in 3, you got 8 over 0. So 8 over a small number. So it should be infinity, right? So you let this one to be your function f. So the first checking is the reciprocal. So you have x minus 3 over 2 to the x, which is 0 over 8. So it's 0. So we know that the function itself, the limit must be either positive or negative infinity. So you check the sign. Again, this one, the exponential, always positive. You should know that. So the sign depends on the one at the bottom. But you are going to consider the x value as you go close to 3 on the right. So it means that your x greater than 3. So roughly speaking, your x minus 3 must be positive, right? However, again, you need to really choose the right area, okay, of that 3, okay, in order to get into, this kind of interval. Okay, so same thing, you can say that this one, your function, which is 2 to the x over x minus 3, it will be, you see, this is positive, and on the top it's positive as well, right? So it is greater than 0 for each and every x inside 3 and 3.1. You don't need to go too far. Okay, just 3.1 will be good enough. So from this one and the positive side, then we can determine that the limit as you go to 3 on the right of this function will goes to positive infinity. Okay, will goes to positive infinity. We get? So how about this one? Again, as you plug in 0, everything will be like 1 over 0, right? So okay, it will be infinity somehow. Okay, and here don't forget that we have the absolute value, and the absolute value, it is x or negative x if your x is non-negative, and if your x is negative, right? And this one, your x goes to 0 on the left, so it means that you need to choose this function value, right? So here, let's say that this one is your f of x. Okay, So the first thing that we need to check is that the limit as your x goes to 0 on the left of this one will be negative, right? Over x squared plus x plus 1, okay? So this one, we already determined that the absolute value of x is negative x. So it will goes to what? 0 over 1, which is 0, okay? So we know that the limit of fx itself, positive infinity or negative infinity. So let us determine the sign, okay? This one will be a little bit tricky, okay? But let's look at your f. Your f of x right now is negative 2x over x squared plus x plus 1, okay? Here, you already combine, right? Okay. So now your x go to 0 from the left. So it means that your x will be negative, right? So if you have a negative value of x multiplied by negative 2, so everything becomes what? Everything here become positive, right? Right. How about at the bottom? At the bottom, you see a square. So one thing that you should keep in mind about the square is the completed square. So here you can rewrite it in terms of this one, right? So it is x squared plus x plus 1/4, is it? So in order to make it equal, so you need to add 3/4, right? And a square actually will be non-negative, but if you add like some number, it will be always positive, okay? So this one will always like the top is positive, the bottom is positive, no matter what, okay? So here you got a positive value. However, again, because we are going to go close to 0 on the left, so you need to like choose the the left bound, okay, for the interval. So we are going to choose just pretty small value, so it can be negative 0.1 to 0, okay? Okay, this one is positive. All right, so it means that the limit as your x goes to 0 on the left of this one, okay, it will goes to positive infinity. It will goes to positive infinity. How about this one on number 4? On number 4, okay, and here your x goes to infinity, right? This one is x squared. This one is x raised to power 1, the highest power, right? So it look like, okay, this one is like, roughly speaking, okay, it look like it dominated by x squared over x. So it's the same as x itself. And your x goes to infinity. So roughly speaking, it should goes to infinity. Okay, this is roughly speaking. So to really check, you need to go through 2 steps again. So you are going to let this one as your f of x. You check a limit of a reciprocal. So 1 over f of x, okay, which is a limit as your x goes to positive infinity of this one. Okay, and then you do the, remember, the pull out the highest power. So we have x, and then what, 1 minus 4 over x, and then we got x squared and 3 plus 3 over x plus 1, okay? And then your x can cancel, right? So you have a limit of 1 over x still left over, and then 1 minus 4 over x over 3 over x plus 1, okay? And then the limit goes to each one of them that has the x, right? So the first one becomes 0, and then this one 1 minus 0 and 0 plus 1. So it is all 0, right? So we know that the limit of the reciprocal already goes to 0. Now we check the sign, okay? So we know that right now we are talking about infinity, okay? So here, look at the top. You have 3x, plus x squared. X squared is always positive. And as your x goes to infinity, 3x should be positive, right? So everything is like positive, add the positive, so it should be positive here, no matter what, is it? But the problem right is right there, x minus 4. So your x minus 4, okay, will be positive if the x go beyond 4, right? If your x go beyond 4. So by going to infinity, it need to go beyond some number, okay? And this number should be like the one that will determine your sign, okay? Only one side for your function. So from here, we know that your f of x, which is this one, okay, will be positive, right? Will be positive if your x start from 5 onward, right? Because if here's 5, it's positive, right? And then all positive added will be positive, okay? For each and every x from 5 onward, okay? So this one is 0. This one determine the sign. Then we can conclude that this limit, okay, of 3x plus x squared over x minus 4 becomes positive infinity. Okay, okay. So for this one, we would like you to do, for example, for this one, we would like you to try, okay, if your x goes to 1 on the right, if your x goes to -1 on the left, if your x goes to -1 on the right. Okay. This one as well, we need you to try if your x goes to 3 on the left. This one, we need you to try if your x, where should we write? Okay. We would like you to try if your x goes to 0 on the right. And this one, we would like you to try if your x goes to -infinity. What will happen? Okay, so please try all this so that we know like how, whether you are really understand what we talking about or not. Okay, so we are going to stop this video clip right here. However, don't forget that for this chapter you may do this following exercise, like for 2.2, 2.3, 2.5, 2.6, and also the chapter 2 review on your textbook. Okay, so please do this exercise so that you really understand what's going on the course. Okay, the good news is that here is the last video clip for the first chapter. So we'll see you on the next video clip of the chapter, the second chapter that we are going to cover. Bye bye.